So I was just looking at a second email from another supervisor who has had students working through Algebra 1, and they basically said all of these distance, rate, time problems on page 21 seem to give a lot of trouble to students. And so I know we went over in the previous video question number, whatever that was, 4 was it? Nope. So on the next page. Yeah, number 5. But let's go back and just talk about some of these others. And again, just enough to set you up and get you thinking about it. And I'm going to show you that drawing a diagram really helps, okay? So let's move quickly, and I just want to help you set these up. Question number 1 says 2 boys are on bicycles. They start from the same place, but they ride in opposite directions. One rides twice as fast as the other. In 3 hours, they are 27 kilometers apart. So let's call this distance 1, distance 2, and in this case, they're not equal, okay? Because they start here, one goes this way, one goes this way, and it says that they are a total of 27 kilometers apart. Do you see that? So we have to add these two distances. So now we're going to do rate 1, time 1. Rate 2, time 2. Now in this problem, what do we know about the times? It says in 3 hours. So guess what? We can just plug in 3 for both of the t's. Okay? And we don't know the rate of the first one, but it tells us that the second one is twice the rate of the first one. So that means 2 times R1. All right, so then we can replace D with R times T. R1 T1 plus R2 T2. And now we'll have all the variables we need. Okay, we can just plug in and solve to find the rate. And again, now in this case, yeah, they're asking for the rate. So you find the slow boy, and then you go back, multiply times 2, and you have the faster one. Let's look at number 2. A man starts out from a city and walks north at a rate of 3 kilometers per hour. 3 hours later, a second man starts from the same place, walks the same route at 4 kilometers per hour. How far will he have to go before he overtakes the first man? So I'm not going to draw the arrow up, even though that's north. All right, so the first guy is heading this direction, distance 1, but he's walking slower. The second guy leaves from the same place, but then he's walking faster. And so at some point, he catches up to him, okay? So it's kind of like this guy leaves and he's going this speed, and then this guy leaves and they meet here, okay? So watch that again. He leaves and he's going slower, and this guy leaves, he's going faster, and they meet. So when it says he overtakes him, it means he met up with him. At that point, they've traveled the same distance. Does that make sense? Then here's the trick with the time. It says 3 hours later, the second man. So they give us both of the rates. What do we do with that 3 hours later? Well, there's 2 things we can think of. I always say take the guy who traveled the shortest length of time, okay, and add the 3 hours to the short guy. It's just something about the way our brain works. You can do subtraction, but I find students do better if they think about who did it the fastest, and that was the second guy. So he was the shortest time, and so the longer time would be the short guy's time plus the 3 hours. He was on the road longer. This guy was on the road for a shorter time before he overtook him and met up with him. So he was traveling faster for less time on the road. The short time plus the 3 equals the long time. Anyways, I just think that's a more helpful way of thinking about those. All right, let's look at number 3. A person climbs to the top of a mountain. It gives us the rate and the way down at a rate of 4.5 kilometers per hour. He's gone for 6 hours. How far did he travel? Okay, same thing. Up the mountain, turn around, come back down the mountain. The 2 distances are equal. Okay, they give you the 2 rates and they give us the total time. Now in the other video I told you what to do with that, where you add the 2 times, set them equal to 6. Okay, Let's look at number 4. How fast must a car travel to overtake a bus in 5 hours if the bus is traveling at 30 kilometers per hour and left 3 hours before the car? So this is this is an overtaking kind of a problem. So they're traveling the same distance. One left earlier is traveling slower. Second one left later but is traveling faster. Now what do we do with, and it gives us one of the time rates. The bus is traveling 30 kilometers per hour. Now it gives us the time of the bus. How far must a car travel to overtake a bus in 5 hours? So the time of the car is 5, and then it says the bus left 3 hours before the car. So just think about that. Who was on the road longer? The bus was on the road longer. We know how long the car was on the road, and the bus was on the road for 3 hours longer. Think about it. You can figure that out, all right? So we know the time, and we know the rate. So there's only one thing we don't know. 6 looks very similar to some of the other ones that we've already done. And let's look at number 7. 2 families are traveling by car to a camp 280 kilometers away. One family leaves 20 minutes ahead of the other family, travels at an average speed of 40 kilometers per hour. What would the speed of the second family's car need to be if the family is to reach the camp at the same time? All right. Now, the fact that they give us 280, we have to use that. So we can't just say distance 1 equals distance 2, okay, because that's not really going to help us this time. So this time we're going to say distance 1 equals 280 and distance 2 equals 280. And then family 1, come on, rate times time, and R2, T2 equals 280. And now we look at the problem. One family leaves 20 minutes ahead of the other family. Now we need to actually convert that to hours. That's the trick here, because the rest of the problem, the rates are in kilometers per hour. So 20 minutes is a fraction of an hour, isn't it? 20 over 60, I'll let you figure that out, but just be careful about that when you set up the time. And 20 minutes ahead of the other family. So travels at an average speed of 40. The thing that we don't know is the rate of the second family. Okay? And this family left 20 minutes ahead, so it's actually time plus 1/3 of an hour. All right, I'm going to stop there and let you figure out the rest of page 22. All right, good luck on that. And then I would suggest meeting with your supervisor and kind of looking over the test, the checkup before you do it, and make sure you know some of those types of problems and at least the main equation you're going to set up, and see if they're similar to some of the homework problems that you did. All right, next.